Hi all and welcome to Scala Collections. In our previous video, we have seen how can we evaluate each and every element of an existing collection to create a new collection. But in real life, when we play around with collections, there are always business scenarios when we tend to filter out the data. Today, we'll look out on how we can manipulate collections to fetch the desired data. Let us jump straight to Scala shell to use recursion to filter out data from a collection. I'll start with a simple method that would filter out all the numbers that are perfect square of some other number. For example, 4 is a square of 2, 9 is a square of 3. The method will filter out 4, 9 and so on. So here I have declared a method find perfect root that would take list of integers. I will match the list. So the first case is an easy one. If the list is empty, I'll return nil. And in second case, if and in second case, I will fetch head of the list. I'll check if the square root of head is whole number, then I will attach head to the final list, else I will skip the head. After evaluating the head, I will call find perfect roots again with tail of the list. Let me call find perfect roots with first 100 integers. And here are all the integers that have perfect square roots. But as we have seen for map and flat map, there must be an easier way for us to write the filter. And let Scala do this kind of recursion in most efficient way. And we are right. We have filter function for all the collections in Scala. Let us write the same filter again. We'll again create a list of first 100 integers and use filter with same condition. And as expected, the result is the same. But what if we want to skip all the perfect squares? So Scala also provide a converse of filter, and that is filter not. Filter not is similar to filter where we have to provide the same condition again, but this time the result is different and we have skipped all the perfect squares as expected. Now let us have a look at another example. Let me declare a class book with attributes name as string, publication as string again, and cost of the book as double. I will create a list of few popular Scala books. Now, I want to pick up a book to study Scala, but I have a limited budget of £30. I want to create a filter that would give me names of the books that I can buy within my budget. First, I will create a filter that would give me a list of books, and then I will map the name from filtered books. And here is the list of books that I can pick up within my budget. I can use filter not to achieve the same result by inverting the Boolean condition. Let us have a look. So I say that I don't want books that are greater than £30, and then I will map over the filtered collection again to fetch all the names. And here I will receive the same result. There are few other helpful functions that we should know while we are filtering our data. First one is find. Find will fetch you the first result from the list that will match the criteria. So let us find out the first book that is below 30 pounds, and the result is Functional Programming in Scala. Quite a good book by Manning Publication to learn about functional programming concepts. It is sometimes referred as Red Book. The result is an option here because Scala was not sure if any book will satisfy the criteria or not. If no book would have satisfied the criteria of our filter, then Scala would have returned us none. Now, this brings us to our next useful function, and that is exist. This helper function is quite handy as well. So consider if there is a huge collection that you are evaluating and you do not want to cycle through the collection before making sure that at least one element of the collection matches your criteria. In that scenario, you can use exist. Exist will return true if at least one element of the collection satisfy the criteria. Let us try to check if at least one book is less than 30 pounds. And indeed, there is a book that is less than 30 pounds, and we have seen that earlier. Finally, I will talk about partition. As the name suggests, the function can split the list into two halves. One that satisfies the criteria, and second that does not. It is a combination of both filter and filter not. I will first take a simple example for first 10 integers to understand the syntax of partition, and then we'll use it with our books example. So I want to split the first 10 integers into two lists, those that are perfect squares and those that are not. So as we know, result should have two lists, first one having 1, 4 and 9, and the second one is everything. As we have seen earlier, I'll use partial function and provide a Boolean condition. And as a result, we get a tuple of lists. Let us apply the same to our books collection with books greater than 30 pounds and the books which are less than 30 pounds or within my budget. I will save the result of partition into a val filter 30. As you can observe, filter 30 is currently showing us all the book objects. However, what we want is the name of the books. So I'll pick up the element of tuple one by one and will cycle through to fetch the book names. So here is the first collection, and it has printed us all the books below 30 pounds. And here is the next one with all the books above 30 pounds. So that was all about filters and other helper functions that we can use to filter out our collections. Recursion examples are always quite handy to understand how these functions work internally. So we have explored filter in quite a detail today, but I think the syntax of filter is still quite confusing. We have to first filter out the books here, and then we need to map over the books to fetch the names. However, Scala is famous for its brevity, and in upcoming videos we would explore how we can use other functions to make our filters even more concise and easy to read and understand. I'll catch you guys in my next video. Thanks for watching. Please post your comments and suggestions.